Right, herewith I show the solution for model paper 4, model paper number 4, applied mathematics structure type. I hope you complete that successfully. So waiting for my answers. So check with me all detailed solution I will publish through this YouTube channel. So first question, two particles A and B of masses lambda m and m are moving each other towards each other opposite direction. One is velocity u, that is A, the other one is this side lambda u, speed or velocity. So what happened, they collide each other. After that they move at different velocities. The question is, after collision, find their respective velocities. And the second part, show that the impulse due to collision. You see all the past papers, recent papers, first question they applied mathematics, such a direct collision between the spheres or like these particles. Simple problem. So I hope you complete this. Check this there for both collide. The initial diagram, if I mark the collision diagram, when collide we usually mark this impulse along the common normal, the I opposite and equal. This is A, here B. This moved with U initially. This is lambda U. So I mark, it's called hit that B and reverse, or wherever you can mark the velocity, no problem, right? So I mark here V1, and this is moving after collision with velocity V2, right? It's the case here. We use two things, what the principle of momentum and the Newton's restitution law. So if I apply principle of momentum, right? Apply principle of momentum toward that direction. What is momentum? Or final momentum equal to initial momentum, right? So if I take a final diagram here, mass of this is lambda m into V1, but this direction V, I applied that side, right? And here plus mass is m, its velocity V2, the system final momentum mass into velocity equal to initial momentum. The same here, this becomes a lambda m into u, is opposite, therefore minus mass m into lambda u. Okay, see that side 0, that side 0, lambda mu minus lambda u, this becomes 0. You can cut this m also, check the answer becomes V2 equal lambda V1. Is it first equation? V2 equal lambda V1, your first equation. Now we apply the Newton's restitution law. So you can write below, apply Newton's law, apply Newton's restitution law. What the law says or rule says, along the common normal, velocity of the separation equal to E into coefficient of restitution into approaching velocity. Relative velocities they both, right? Therefore separation, if the both goes a part of them, that is sum of the velocity, no? Therefore V1 plus V2 equal coefficient into, the same case here, both approach velocity. One is u, one is lambda times u, that is u plus lambda u. Otherwise what? V1 plus V2 equal, take the u out, it becomes 1 plus lambda. Okay, it's your second equation. Apply the Newton's restitution law. Now solve. Find, the question is what? Find the V1, find the V2 after collision, what their speeds. So you can substitute simply or subtract whatever solve method. 1, 2 gives you V1 plus V2 is lambda V1 equal EU into 1 plus lambda. Okay, so if take the V1, take out 1 plus lambda cancel, is it? Therefore V1 answer is E times U. Okay, that is this velocity E times U. So what is V2 from the first equation? V2 equal lambda times V1. So lambda EU. Like this, these are the respective speeds after the collision. First part is over. So second part they given that show the impulse. Okay, show the impulse due to collision. Like this, show the impulse due to collision. That so those newcomers, you can view my this model paper, the previous video I published. Stop the video, better you go through and or take a snap, so the screenshot, anything you can take that video proper, that exam paper, the model paper there, and only you know what this question says. Okay, now we apply this I value. To find the I impulse, we have formula. What is that? Impulse equal to change in momentum. Impulse of a sphere, particle or collision case. Impulse equal to change in momentum, or we call what I equal delta mv. So next apply I equal delta mean change. Delta mean is a vector equation. I equal delta mean change, right? Instantaneous change called delta. So we apply for any one of this particle, we apply one of this, either A or B, whatever it is, they can get the answer. So I apply for the what B, I apply for particle B, right? So I that side, right? Positive I equal mass of the particle, that is small m. What is delta mv? Velocity change, final minus initial. Final V2 minus initial lambda u this side, but I am applying that side, therefore minus lambda u, okay, right. If the V2 is correct, you can get the answer. If V2 wrong, you can't apply this. So I equal small m into V2 is lambda EU plus lambda U. So I equal m, take lambda U out, 1 plus E is the impulse due to the collision, right? Simple question is the question. You can see all the past exam. These are the problem available. Very simple. You can minimize your time. I hope this I took nearly 8 minutes to explain. But the exam, you want to explain for others, you can work, I think 3 or 4 minutes, half of that. So second question. As a projectile important question, important idea. Projectile, it was earlier, projectile big problem, the essay problem, essay question. But last many years they ask in the structure type paper 1 problem. So what they say is a particle projected by making an angle alpha to the horizontal velocity u. A particle usual method. A particle, I show the exercise and drawing like this. A particle with an angle alpha, velocity u, right? A particle projected, we say time is 0 initially. Time is 0, particle is projected by making angle alpha with the horizontal. After time 2u over root 3g, it's projecting, time is 0, and somewhere here, if I mark somewhere here, this time is 2u over square root 3g. After this time, and the distance s from the projected point, here the distance is s. Okay, the diagram import you mark, sometimes you confuse what this time mean, what the distance mean. It's the case, right? Distance from here, there is s. After that distance and this time, as from the projection point, particle move right angle to the initial direction. So very important idea. Initially I project like the angle alpha with the horizon angle alpha. This is the initial direction, right? This is the initial direction. So after this time duration, what happened? Its motion of the particle or direction is changed. Its direction is changed. There's a right angle to the initial motion, initial direction. So how I can show that idea? If I produce the initial original direction, initial like this, later after time t, if I draw here, here this is, if I say for example v, this is the speed here v, does not matter for the problem I think. This both direction right angle to each other's idea very important, otherwise you can't complete the problems. Many questions we have something like this, or perpendicular to each other the motion projected cases. So it's the idea, right? Then you show u equal 3gs over 2 square root. Show this projectile velocity equal to that, right? So is the case, initial time is 0, after time this, if I mark the speed v, the original direction, this one, make change here by right angle, right? Okay. So what the idea? First I want to find the angle. So if I mark somewhere here like this is y, this is x. So you apply the Pythagoras relation after finding the x value and the y value. You can find the s relation, simple idea hereafter. But first point is if you break such a point, the difficulty on that tricky. If you break the tricky, then hereafter this becomes simple ordinary Pythagoras theorem. So first we find the alpha angle, right? Because time is given to apply this u cos alpha, u sin alpha, no matter. U is no matter. You will find the u value. Find the angle alpha. For that, I apply v equal u plus at or ft formula. Final velocity equal initial into acceleration time plus acceleration time. We apply along this direction, along this original initial direction, the initial direction but the final velocity. This direction here, but the final velocity here 0 because it goes right angle, no? It moving right angle down, not at that direction. So therefore v cos 90 is 0. If you resolve v cos 90 is 0, I mentioned v, final speed is v. V cos 90 is 0 because of initial direction perpendicular to the final direction. Therefore the best thing, we apply along this initial direction this formula. My target to find the alpha, that's the important part, right? Therefore what is v0? Initially that is u, don't mind u cos alpha, not u sin. This direction applying, the applying directions are important. That is u. What that acceleration, you know, the undergravity is one of the undergravity motion types. So we find the g component is what after time this t, right? This is time t. So if I mark somewhere here, see always gravity downwards, no gravity downward like this. So how the angle here alpha here 90, this is 90 minus alpha, is it? And here also alpha, right? Okay, that therefore, but the g component, g cos 90 minus alpha, g cos 90 minus alpha, g sin alpha, right? Minus downwards. So minus g sin alpha into t. T means you know the t answer, right? Therefore, g sin alpha, what is t is 2u over square root 3g is u. So you can find alpha here, it's simple now. G cancel, u cancel, sin alpha equal to root 3 by 2. Therefore alpha 60 degrees or pi by 3, right? Therefore alpha equals 60 degrees. This is the major part of this solvable. Can be solved hereafter if you break this part by finding the angle of projection. Now here I mentioned earlier, use the that formula SC equal ut plus half ft square up to time t. At time equal that 2u over root 3g, apply SC equal ut plus half at or ft square. Some applied means we use the S not A, no matter whatever, F or A. So if I apply horizontally x, okay, displacement x equal u cos alpha into t. X, projectile, no horizontal acceleration. So what is that? X equal u cos 60, alpha is 60, time is 2u over root 3g. 2u over root 3g. So simplify, get an answer. So cos 60 is half, right? Half, 2 cancel. So u square over root 3g is it. This is x value, horizontal displacement. We are applying this S equal ut plus half ft square. It becomes like that. Now we find the y vertical component. Apply vertically after time that given duration t. Vertically I said y, right? Y equal u sine alpha into t minus half g t square. Okay, this ordinary method. You only there is applying along the direction, original direction, right? This ordinary method. So y equal what? U sine 60 t equal 2u over root 3g minus half g t square 2u over root 3g whole thing square. So we have to find xy, apply the Pythagoras, right? So what is that? Y equal sine 60 root 3 by 2, sine 60 root 3 by 2. So root 3 cancel, 2 cancel, is it? Therefore u square over g, sine 60 root 3 by 2, 2 cancel, root 3 cancel, u square over g, right? Minus here what? If I simplify half g into 4u square over 3g square. Okay, so what is that? Y answer u square, cut the g also, u square here g minus cut the 2 here, 2u square over that is 3g. So using the LCM it becomes 3 here 1 u square over 3g. Okay, so good question for a well balanced for the expect in the future exam. U square over 3g. Now you know this method here. I erase the diagram. I mark here x and y. S. So Pythagoras relation. Therefore s square equal x square plus y square. What is square of the x? U to the power 4 over what? 3g square. What is square of the y? U to the power 4 over 9g square. Okay. Then how this happen? You can see s square equal the LCM 9g square. 9g square, therefore you have 3 and 4, is it? 4u to the power 4. Okay, so put the square root over there, the u answer is find the u value, then you subject the u power 4. So u to the power 4 is 9s square g square over 4. So square of a square, no, square of a square. Therefore, what is u square? U square is what? Take the square root. 3sg over 2. So what is u? This answer. U is that, right? A good question. Timing important is the idea. Many questions there. I will show many in the future also. Yes. If you follow my regular this video series, you can get good idea, knowledge, how to work, maybe various method. So I have to show a simple, applicable method within short period but full marks. Next question number 3. That is a vector problem. Vector A and vector C are two unit vectors. Therefore, you know what is unit vector? It's modulus. Mod A is 1, mod C is 1, right? Unit vector is magnitude is 1. I have many series of vectors. Newcomers, you can view that. But I will try to complete 30 questions and the 2 videos or 1 video. In the future, I will publish that. A and C are 2 unit vectors. And another new vector showing B. That is vector B modulus equal 4. And the angle between vector A and C. Vectors 2 questions come in the part 1 problem, essay also and the problem. Vector A and C, angle is given as a theta. Here what is cos theta? They said cos theta 1 over 4. That is there, right? There's important part, equation given or relation between the all 3 vectors A, B and C is this. Okay. Then the question, find the possible values of lambda. In my video series also you can see many problems I shown something like this. This under what scalar product problem, idea of the dot product cos theta A dot B, mod A mod B cos theta idea. It's the important equation given. From that only you can go ahead to the answer. So how these can make these you see A and C, the angles known for the A and C. Therefore, better you take these B equal to lambda A plus 2C, is it? Because when you do the product between A and C, the angle known, not for the B and C, right? Next what? Both sides, product itself, you can write product itself both sides. It means square to square. Multiple itself like that. So therefore B dot B equal lambda vector A plus 2 vector C dot lambda vector A plus 2 vector C, product itself. So you know what is B dot B means mod B cos no, the angle between B and B, that is 0. Therefore we call this mod B square. Mod B square. If you multiply what happen, A dot A once again mod A square, but lambda square, no? Lambda square mod A square. And this one, then multiply this 2 times A C and again 2 times A lambda C 4 times. So plus 4 lambda A dot C, is it? Here 2 lambda A dot C once again. It's again plus B all things square, no? A square plus 2AB plus B square form, right? At last what? 2 to 4 C dot C mod C square. Okay, now what they given in the further detail, mod B is 4, other 2 are unit vectors. So apply the value. Mod B 4 means square is 16. Here A is 1, therefore lambda square 4 lambda. What is A dot C? That's the application of this dot product. A dot C, the angle also given there. That is mod A mod C into cos theta. This is 4. Mod C is 1, therefore 4, right? And for the simplify, get an equation, quadratic equation in terms of lambda. Here you know A is 1, C is 0, cos theta is 4, 1 over 4, cos theta 1 over 4, 4 cancel, right? Therefore A1, C1, therefore only lambda, is it? Lambda plus 4. Therefore your quadratic equation becomes lambda square plus lambda minus 12 equal to 0. The question is find the possible values of lambda. So 2 chance for a lambda, right? In fact, factorizing lambda by plus 4 and 3. Therefore lambda equal minus 4 or lambda equal 3. Both values can be taken, right? No, and you can take the both answer. Lambda relation between A, B, C, both satisfy the given equation. Is that question? Next problem 4. That's the work, power, energy. The important problem for structure type. Was the previous papers I shown one question. So read properly, step by step, draw by diagram and mark and find some unknown term and complete the problem. In work, power, energy, use only 2 formula, but one is Newton's law, F equal ma. Other one is the power equal tractive force into velocity, H equal PV. Most question that 2 are the application. Sometimes energy, kinetic energy or potential of mv square mgh, that also involved. I will continue to show many problem in this video series. So the maximum power of an engine of a vehicle of mass is m is capital H. They say power is capital H. When the vehicle moves on an inclined plane which incline angle alpha to the horizontal, its frictional resistance force is R. That is constant. R is constant. The maximum velocity attained by the vehicle. What do you mean maximum velocity? Mean constant. If you know the VT graph problems, when you draw the acceleration, take the maximum and moving on that velocity. Maximum velocity mean acceleration 0 part. The maximum velocity attained by the vehicle when it's moved upward is 2v. If the maximum acceleration gained by vehicle move upward, so many people properly read. Those newcomers, better thing, stop the video, take the problem video I published in the previous video, finish it and come, otherwise useless of watching this data problem only, data waste only. So better thing you draw this diagram for the each and every case we find some unknown, because they say moving upwards. So the angle is alpha. The first occasion, they said mass is m, therefore you know the weight at mg, and the resistance is, they say R, it's the constant part R, and the maximum velocity, they say 2v maximum velocity. So as a result, acceleration is 0. Acceleration is 0. And also if it can't move like this, it can't move because no tractive force. Therefore you have to mark that one. I say P. P is the tractive force to go ahead along this inclined plane upwards. So therefore the first occasion is this. So we connect it. So in this case actually R is, they said what is R. I mentioned P. So I want to get relation in terms of P, R, everything. So first you have to, but the question if you go and they ask finally what the question, find the maximum velocity attained by the vehicle when it move downward in terms of V. Down this later. So then there are 3 occasions here. If you go through properly step by step this problem, identify the problem, draw. Most question by diagrammatically you can feel the easy types of this. You can feel easier than without drawing diagram with the diagram. Okay, so here I would apply our usual formula. So I apply Newton's law formula first, F equal ma. First I apply F equal ma formula along the slope upwards. So what the resultant force P up R up mg component also here. Therefore P minus R, here what alpha 90 minus alpha, familiar thing for us, mg sin alpha, right? Minus mg sin alpha, mass is m but acceleration 0. Why 0? Maximum velocity means no acceleration. Therefore your answer P minus R equal mg sin alpha. I say my first equation, right? First equation. So here I mentioned the P is unknown, therefore better you complete the P answer. Now our best formula for only this lesson, we use that formula. That holds what you call the power. Power equal to tractive force into velocity. Next you apply H equal to PV formula. H equal PV formula. What they said H and P velocity 2V, second equation. Now solve these two, we get relation by removing the P, because P not necessary. I mentioned the P, so remove the P and try to find H and R relation first. So first 1, 2, H equal, what is P? Can I subject P equal mg sin alpha plus R, right? So here you can put that mg sin alpha plus R into 2V. Okay, can I say 2V, 2 here or V here, or 2V here, check that. H equal 2V into mg sin alpha, R plus mg sin alpha. So only this data we can collect from this information. Is the result we can collect from this information data. Okay, so further they said, if the maximum acceleration gained by the vehicle when it moves upward with the velocity v is 6g sin alpha. Another occasion, so better show new diagram, mark the detail. The particle again moving upwards. So in this case maximum acceleration is they provide. So that is you can go to see 6g sin alpha, right? 6g sin alpha maximum velocity. At that case the maximum acceleration 6g sin alpha. Velocity is v. Velocity is v. Velocity is v. And here also resistance, they said that R is constant. Wherever it moves horizontally or inclined plane or downward, upward, they mention R is constant. So here also there's a tractive force that is different. That is we have to manage it. So I mark some data here. I said that P1 or P1, P2, no matter whatever you mark. So the second case of this problem. So again apply the same idea. So I want to find the P1, you know the relation in terms of H and V. Your V, some relation we can take out. So first to complete the same method, apply F equal ma. Apply F equal ma upwards P1, okay, P1 minus R minus mg cos alpha sin alpha. Okay, it's the total force, resultant force upwards equal mass into acceleration. Mass into acceleration, mass is m. What is acceleration? They say 6g sin alpha. 6g sin alpha. Okay. Therefore, P1 minus R equal to 7 mg sin alpha, is it? I said my third equation. Now I want to complete I want to vanish or eliminate my attractive force P1. So next I apply the H equal PV formula. Apply H equal PV formula. So power is given as a constant for any engine. Power is a constant. Power is off. They comes to make the switch off for the power of the engine, or it's smooth. If it's smooth, the power is H. So therefore apply this once again. H equal P1. Here velocity V, right? I said my fourth equation. Connect the 3 and 4. Remove the P1. So you'll get the equation in terms of H, R, V, also sin alpha. Connect the 3 and 4. Do that work. Removing that part. An easy method. If I take from third equation, P1 equal 7 mg sin alpha plus R. If I say once again third equation, connect the 3 and 4, substitute. So 3, 4 is H equal 7 mg sin alpha plus R into E. Is it okay? 7 mg sin alpha, the P, that one answer. You know the H, the H also, the H answer. Try to find the capital R value, because the question finally, if it goes step by step to the third occasion, they ask find the maximum velocity attained by the vehicle. So maximum velocity only V, meters per second, okay, h minus 1, no other dimensions. Yeah, here you come put the H answer, put this H value, the H answer. So therefore now finally H4 2V mg sin alpha plus R equal 7 mg sin alpha plus R into V. So see V cancel. You can say 2 mg, 7 mg, 5 mg sin alpha equal to R. Check that. So I found this resistance, constant resistance, yes, because incline is constant, mass is constant, gravity, therefore resistance is a constant part, 5 mg sin alpha. Okay, so the second occasion you can obtain that ideas. Now finally what happened? Find the maximum velocity attained by the vehicle when it moved downwards. We use that third diagram. Third diagram, same inclined plane, it's moving downwards. So in this case I show P2, tractive force is P2, but the forces they are mg, R, and maximum is a maximum velocity, right? Find the maximum velocity of acceleration 0. F is 0. I say maximum velocity W. I write W. So find the W answer in terms of V, right? Write the W answer in terms of V. So apply same method, apply the Newton's law and H equal PV formula. So apply F equal MA downwards, in this case downwards, right? mg sin alpha plus P2 minus resistance R equals 0. Mass is available but the acceleration 0, right? Therefore, first you complete your P2 answer. Therefore, P2 answer is R minus mg sin alpha. So you know the R here, you see R is 5 mg sin alpha, therefore 4 mg, right? Therefore, P2 equal 4 mg sin alpha. See, nice question. You can learn a lot of ideas through this, my explanation, my problems. So 4 mg. Now finally apply the H equal PV formula. Apply the power is equal to attractive force into velocity downwards. That is H P2 in this case. Velocity there, I said W. I said velocity is W. So apply every, you know, the H value and the P2 known. Apply everything and find the answer. You know the chance, there. Already mentioned a chance. R also known, you can apply the R there. What happen if you apply this R? See, if you apply this R, 12 mg sin alpha is it? Substitute this H4 or the 7 mg, 12 mg is it? 12 mg sin alpha into V. Okay. So what is P2? P2 equal 4 mg sin alpha into W. So mg sin alpha off. So what answer? W equal to what? 3V. Yes. W equal in terms of V they ask. W equal to 3V. It's a nice practice question before final paper. It's the type you can see 2019, 2018, 17. It's the model structure paper. Right? We see question number 5. That is Newton's law of motion. Once again, like an inclined plane. Diagram available. Inclined 30 degrees plane. A particle here attached to by string and like this, and the particle, this is, they say, Q of mass Km, this is P of mass M. The diagram PAQ is a small pulley here, small pulley. PAQ is a light inextensible string attached to a particle of mass M kilogram. And other one is there is rough plane. There's a rough plane here. The string passes over fixed small smooth pulley at A, attached to the another particle Km mass, K greater than 0, K is positive. PA is lie along the greater slope of the AQ, that is lie along greater slope. The coefficient of the mu is given. Here mu equal to 1 over 2 root 3 between the plane and the particle P. The system released from rest when the string is towed show that particle descend. Q descend, that means it's go up. Yeah. Ascend, descend, comes up, down. It's called ascend, descend, meaning show that if its K is comes down, descending, it goes up, we got ascending here, descending, right? Everything depending on the forming equation, find the acceleration and do that work. So if I do diagram here, for the force diagram, mark this one is a Km, right? This is Kmg. This is mg. So I take it comes down, let's say K is positive, K greater than 0. For example, K is 2, then 2m, K is 5, 5m, but here 1m. So possible force comes down here, no more is more greater weight than this. Therefore I mark this comes down, acceleration F. Same string, therefore it also goes by acceleration F. And tension force available T, opposite and equal T, here T. Same string, therefore tension is same. And it goes up, friction, oppose the motion, friction. Therefore, if I mark the resistance, reaction here are opposite and equal, then you know what the friction force F equal mu R. F equal to mu R, right? Everything I shown the diagram, F equal to mu R. So if you know R, you can find M. So the idea is by using the formula, you find the small f answer. In I mentioned f is downward. If f become positive, then problem is okay. They say somewhere k greater than 3 over 4. If k greater than 3 over 4 only, this my diagram valid. That's we have to show, right? K more than 3 over 4 only, this diagram is valid. That means this q particle comes down. Okay. So I think very first we will better find the friction force, then you can use the Newton's formula. The T is unknown. So if I apply for the particle P, apply for P, F equal ma. For particle P, apply. For P, we apply P perpendicular to the slope, but the force apply R here. For particle this R, to the slope this R, right? Here downwards. Here so R, then what? Here at 30, here 60, mg cos 60, mg sin 60, okay? Minus mg sin 60 equal to mass is m. What the acceleration, particle moving along the slope, not jump or project upward, therefore 0. Therefore along this perpendicular particle is under static like that. So that R equal mg sin 60 root 3 by 2. So that is the reaction exerted by the plan, friction plan, right? Okay. Therefore, you know the friction force. Therefore, what is F equal mu R? F equal to mu times R. So mu is given 1 over 2 root 3 into R equal root 3 mg over 2. 3 cancel 4. mg by 4. Okay, friction force is mg by 4 and the important part. So now we use the Newton's, this question under the Newton's application, one of the part in the structure. Also essay big problem, wedge problem, or sometimes pulley, the systems of pulley. Okay, now I apply F equal ma, apply F equal ma for Q, apply for Q. If I apply downwards, 4 mg weight of the Q minus T mass 4m acceleration F, right? I said my first equation. So here F is unknown, T is unknown. Therefore, you need two unknowns, two equations. So I come to the next particle P. Apply particle P upwards. Apply upwards. Then what is that? T. T upwards. Minus mg sin 60. Okay. Minus mg sin 60. Also capital F O mu R, right? You know that F, okay, right? Mg by 4, right? Minus mg by 4 equal mass is small m, acceleration f. That's all. Applied maths. Now solving idea, use the pure mathematics. Systems of equations, solve and complete the answer. So try to remove the t. If you remove the t, you can get the answer. Add the 1 and 2. 1 plus 2. But that 4mg minus t plus t cancel. Yeah, but that minus mg sine 60 root 3 by 2. Minus mg by 4. Other side 5mf. Is it? Oh, I missed that. That's k. K comes k, where the k is k. K, not 4, no k. Kmg. K. K and a km, km is km, right? Km, not 4, km. That's where write properly if you write. So it looks like 4 also. Write properly km. So in this case we add the both k plus 1 mf. Is it? K plus 1 mf. Now simply we can cut this m, cancel m, cancel. Therefore, if I use it, take the what? 4g minus root 3 by 2g minus g by 4 equal k plus 1 into f. So if I use the LCM idea, 4 is the LCM, then take the g out. What the part here? 4 here. 16 minus 15. G, here 2 root 3 minus 1, g is out, equal to k plus 1. Is it okay? Somewhere missing in the 16. Yes, sir. So yes, I missed that k problem. K is a problem. You can check your own. See that. See, actually kmg. No kmg. See one missing row or everything problem. Kmg. So if I add 1 plus 2, 1 plus 2. See time waste, data waste. My issue. See 1 plus 2 cancel. Can I take the mg out? At that kmg minus mg sine 60 minus mg by 4 equal, take the mf out, therefore once again k plus 1. Okay, so this m cancel, m is okay, m cancel. So if we take the k out, that is g k sine 60 root 3 by 2. This is 1/4 equal f into k plus 1. Yeah, cos 60, that cos 60, no, cos 60. So here sine 60 perpendicular, here cos 60. So you can see the answer comes from cos 60. Cos 60 is half. So my mistake, check that. G into k minus 3 over 4 equal f into k plus 1. So what is f equal? Simple question, I made mistake many times. The k problem and I missed the cos theta also. So what is f equal? G into k minus 3 over 4 over k plus 1. K plus 1. This is f. Now they say there, see if k greater than 3 over 4, what happened? If k is more than 3 over 4, this is positive. K larger than that, therefore particle comes down as usual. We show the diagram. So if k greater than 3 over 4, f greater than 0, therefore the particle q descend or comes downwards. That's the meaning, right?